Right, so we continue to look at the fundamentals of precalculus, and in this particular instance, we are focusing on the algebraic expressions. So algebraic expressions are important because I think all of mathematics somehow comes back to these basic principles. So even if you are doing limits, even if you are doing um, integration, you're doing all those advanced concepts in physics, in maths, you still need to understand how basic expressions are simplified, okay, or are um, integrated into each other. So algebraic expressions, first of all, to define them, these are mathematical statements or expressions that contain variables, that contain numbers, powers, roots, and operations, and return a value, okay, um, given specific conditions or given certain conditions. Now, variables could be like an X, Y, a Z, and things like that. Numbers could be any number, real numbers. We looked at these. There could be powers. Remember, we did exponents. There could be roots. We looked at the radicals. Um, there could be operations. If you look at real numbers, their properties, you'll see various operations that we can do with real numbers. So if you're not very clear with this, we did a number of videos that you can still look at. This is a playlist, so maybe try to start from the first video up to this video to enhance your understanding. So this is an example of an expression. It contains exponents. It contains the product here. It contains the constant there. Here it contains it's another statement that is made up of two statements. Okay, so the first statement has got these terms, and then the second statement has got those terms. The second divides into the first, then you have a new expression. This is another expression here. You have 6x9 y2 power -1/3. So this is another expression, and you could actually simplify this into the radical, something like this. Okay, so now with algebraic expressions, one of the most important concepts to understand is the degree of, we can say the degree of the term or the degree of the expression itself. Why is that important? It really tells you how that equation can be manipulated when you're factoring it or when you're expanding it. It also tells you when you are trying to combine or separate equations, because this is also what you find in advanced mathematics. You've got to be able to simplify and then act, okay? So now you have to be able to understand the degree of an expression. So for example, we give a few examples here. What would be the degree here? We look at the highest power here. So that degree here would be 2. What will be the degree here? The degree will be what? Will be 6 here. What will be the degree here? Remember, this is same as x0. That is the same as x0. So what's the degree here? It's 6. What's the degree here? To be 10. What will be the degree of this expression here? You don't just look at the first one. You have to compare all of them. So this is the highest power. That's the degree. So whenever you're asked or whenever you have to look at an expression, it's very important to see the highest power, and then you understand how you will work with that expression from there. Okay, so these are some of the expressions that you can come across as you are advancing in your calculus at all. So now when you see expressions like this, usually you want to simplify them. And you simplify so that you can apply the concepts that you want to apply on them. Or maybe you might be trying to integrate, maybe you might be trying to find a limit. You still need to be able to simplify. For example, this last one here, you might get a question that says maybe find the limit of this equation as you are approaching -1. Now, if you put -1 here, you'll see that you get a 0. And that's 0, you can't divide by 0, isn't it? So that becomes undefined. So you need to simplify it, get rid of this component here, and then apply your limit. So it's really these basics that work even when you go to advanced level subjects. Okay, so let's go through them one by one. So the first one we said is x squared plus x squared plus 2x. Now, what is important is to understand these are obviously the variable is x, okay? So meaning that there's a chance that we can add all of them together. But here again we can't because the powers are different, okay? So we can't add them. So what we do is we choose to put the ones that have got same variables and same powers together. So we do like that, and then we'll get x squared like that. So we get these two, and we've put them together. Then we get this x, and we get that 2x, and we put them together. Okay, so this is 2x squared plus 3x. That's our simplified form of this equation. Then we look at the second equation. So we have y4 plus 6y squared plus 8y4, like that. Again, here we check, do we have the same variables? Yes, all of them are same variables. Have they got the same powers? We only have two that have got the same powers. So what we do is we put these ones together with the same variables and same powers, like that. Then we have this one that will be left alone there. So now look at this. This gives us 9y4 plus 6y squared. So you've simplified. You can even go further here. Take a 3 out. We know that a y squared can go in. So we have 3y squared plus 2, like that. That's more simplified than this one here. Okay. So let's look at another example. The third example, let me get a new page for the third example. The third example is x 3 minus 6x squared plus 2x plus 4 minus, okay, so this is in brackets like that. And then we have x 3 plus 5x squared minus 7x. Now, here, what we need to focus on is obviously, again, the variables. So I'm checking, this is same. We've got same variables. So the variable is the same, it's x. Let's look at the powers, 3, 2, 1, 3, 2, 1, okay? Because this is 1, and that's x0, this is 1, like that. So I see we have, I've got 3 sets of things that I can add. So I'll get x3, and then I'll get I'll first maybe expand it first. Okay, so I'll get 6x squared plus 2x plus 4. Okay, then I have x3. The minus, remember what we did in the file for properties of real numbers. So you can still go back there and go through if you're not very sure what happens with positives and minuses and minuses. Yes. So this is positive times minus, you get a minus. Here you get a minus because again it's positive and negative. Then positive times positive, it gives us a positive, right? So this is 7x, right? So that's the expansion. Then I'm going to collect like terms. So this is going to be like that. Okay. Then this. Now I'm going to separate them with the positive so that I still maintain the signs that are in front of my terms. Okay. So that I don't complicate my situation. Okay? Always try to make it simple and easy for yourself. Then I see that I've got a 4 and I see that I've got a 7x here. So I'll get a 7x because I'll get a 7x and then I've got a 2 here, then plus 2x. Then I've got a 4 that's going to stand alone there. Okay, so this I can already see that I can cancel. Then these can work together here, minus and minus. They give me minus 11x squared. This one gives me plus 9x. Okay, then this one gives me plus 4. So that's my simplified form of this equation or expression rather. Okay, so let's look at the fourth example. Okay, so our fourth example is 1 plus root x. So in our radicals file, we said that when there's no number, that small number in front of the radical sign, then we know that it's a square root. So we know that it's a square root here as well and there. Okay, so those are also important. Now there's a video where we did the expansion of these. So here I'll show, but then if you want to master, you can still go to that video. So now to master, we said that to separate these, we said that we split the first one or the second one, and then each you multiply the second factor by each of these. So here I'll say 1, I multiply the second factor, which is 3 root x, like that. Then I take the second, there's a positive sign in front of it, so I'll do that. Then I'll multiply this, like that. So these are radicals, okay? And then I'll multiply by 2 here. 2 by 1 is that. Then I multiply by 1 here. I still get 3 root x. Then plus. Now, this by that will give us 2 root x, like that. Then this and that will give us positive times minus, will get us a minus. There's a 1 in front here, and a 3 here. So we get 3. But then there's this and that. So we combine those factors together like that. Okay. Now I can go on and look at this. Now, if you look at this, okay, and you look at this, they're similar. They're not complicated. This is root x is the same as x half, like that. So meaning that these have got the same variables and then they've got the same powers. So meaning that we can add them. So we can add these two. Add these two, I get this radical sign here. Okay. Because these are subtracting way. Okay. And then we go to this one here, okay? And normally just change one part and then continue with the rest. So I'll continue like this. Okay. Now, again, this we said is half. Okay. It's x half. Now, if you look at our file for exponents, you'll see that if I have x half times x half, we said that we add the powers. So this will be x half plus half, which means that it's x half plus half, we get a 1, which is x. So this then becomes x. So we have 2 minus root x minus, this will become 3x, like that. So this is the simplified form of this equation. Okay, so we look at the last one. Now, the last one we said was, let's say you reach at this point where you have x squared plus, and then you have x plus 1. Okay, then you have something like this. Okay, so remember I gave an example where I said, for example, if they say you find the limit, okay, x as it's approaching -1 for this equation, which is x squared plus 1 over x plus 1 plus 1. So this you cannot just put in this value here, okay, because if you took this and put it here, that gives you 0. So you know that it will be undefined because you can't divide by 0. So what do? You begin by simplifying this expression. So how do you simplify this? You simplify this by checking a number of things. So what things can we check here? We can check, first of all, how to get rid of this. So there are multiple ways. The first way is I can just go on and factorize the top part like that. Then I add 1 and then I divide here. Okay. So that's the pattern I've recognized. And then you can cancel those. Then what you have is x plus 1, like that. Now you can put the limit, then the limit will be 0. It can be 0, but it can't be undefined. Okay. Another way that you can do this is obviously a more complicated way, but it's not necessary in this situation, but sometimes it can be. So in this case, just in case these were not divisible, for example, okay, if these were not divisible, I would go on and expand this. So I will say x squared plus x, then this I will simplify like this. I'll use my lowest common multiple. Then if I divided that into this, it will give me that one. If I divided by 1 into this, it will give me that. That's why I've multiplied that. Then x squared plus x, then plus x plus 1 over x plus 1, like that. Now I know it's not supposed to be this complicated, but there will be cases where you can't immediately divide. That's why I'm showing this. Then you factorize this. Okay, remember we did factorization of this, so that will become x plus 1, like that, over x plus 1. Then we get rid of those two, then we have x plus 1. You'll see that this is same. Okay, so you've got to be able to recognize the patterns, and that comes with a lot of practice. And I can assure you, if you follow these small steps that we're taking, step by step, you'll have a very deep understanding of more advanced topics as they come. Thank you so much. So next time we will still look at how to manipulate these expressions, because I believe this is probably one of the most important things you can learn in mathematics. So we need to look at a number of these. We'll look at how we can multiply them, how we can factorize, how we can divide, and then we proceed to other topics. Thank you so much for watching, and all the best.